In this video, we're going to talk about how to solve some very basic acid-base problems in chemistry, like this one. What is the pH of the solution if the hydronium ion concentration is 2.5 times 10 to the minus 4 moles per liter? So I want you to be familiar with some common equations and how to use them. The first formula you need to know is that the pH is equal to negative log of the hydronium ion concentration. Now, before you use a calculator, what do you think the pH is going to be if you had to estimate a range for it? What would you say? Now, the first number you should look at is the exponent, negative 4. The pH is going to be close to 4. Now, do you think it's going to be 3 to 4 or somewhere between 4 to 5? If this number here is greater than 1, choose the lower region. If it's less than 1, let's say if it was like 0.4 times 10 to the minus 4, I would choose this value. So we know it's somewhere between 3 to 4. Now let's go ahead and plug it in and see what the exact value is. So if we type in negative log 2.5 times 10 to the minus 4, this will give us a pH value of 3.6, which is indeed between 3 to 4. So that's how you can get like a ballpark answer just by looking at this if you don't have access to a calculator. Now let's see what the pH of this solution will be. So if we type in negative log 0.4 times 10 to the minus 4, that will give you a value of 4.4, which is between 4 and 5. Number 2, the pOH of the solution is 4.5. Calculate the pH of the solution. So, that's another simple question. What formula do we need in order to calculate the pH given the pOH? So here's the next equation that you want to write. You should add it to your list of equations for acids and bases. The pH plus the pOH of a solution must add to 14, especially at 25 degrees Celsius, because Kw, the autoionization constant of water, is 1 times 10 to the minus 14. So to calculate the pH, it's simply going to be 14 minus the pOH. And so that's going to be 14 minus 4.5. Now 14 minus 4 is 10, and 10 minus 0.5 is 9.5. So this is the pH of the solution. Now here's a question for you. At 25 degrees Celsius, would you say this solution is acidic, basic, or neutral? What would you say? Now, it's important to understand that if the pH is less than 7, we have an acidic solution. If the pH is equal to 7 at 25 degrees Celsius, the solution is neutral. But in our example, because the pH is greater than 7, we have a basic solution. So in the basic solution, the amount of hydroxide is greater than the amount of hydronium ions in a solution, if it's basic, which it is. So 9.5 is the answer for this problem. Number 3, if the pOH is 3.8, what is the hydroxide concentration? Now, we know that the pH is equal to the negative log of the hydronium ion concentration. So therefore, it stands to reason that the pOH must be equal to negative log of the hydroxide concentration. So we need to solve for this. So how can we rearrange this equation? Well, let's do a basic review of logs. Let's say if we have log base A of B, which is equal to C. You could change that equation from its logarithmic form to its exponential form by doing this. A raised to the C is equal to B. Now the base of a log is 10. So first we need to move the negative sign to the other side. So negative pOH is equal to log base 10 of the hydroxide concentration. So therefore we can say that 10 raised to the negative pOH is equal to the hydroxide concentration. And so this is the formula that you want to add to your list, because that's what you're going to use to get the hydroxide concentration. So it's 10 raised to the negative 3.8. And so that comes out to be 1.0 0.58 times 10 to the minus 4 moles per liter. So that's how you can calculate the hydroxide concentration if you're given the pOH of the solution. Number 4. What is the pOH of the solution if the H3O plus concentration is 4.2 times 10 to the minus 3? So go ahead and pause the video and try this if you want to. Now the first thing I recommend doing is calculating the pH of the solution, which is negative log of the hydronium ion concentration, which we already have, and that's 4.2 times 10 to the minus 3. So looking at this number, we know that the pH is going to be somewhere between 2 and 3. So if you type that in, this is going to give us a pH of 2.377. So now we can calculate the pOH by looking at, or using this formula rather. The pOH is going to be 14 minus the pH of the solution. So that's 14 minus 2.377. And that works out to be 11.623. So that's the pOH of the solution. Number 5. If the Ka of an acid is 1.8 times 10 to the minus 5, calculate the pKa and pKb values of the acid. So let's start with the pKa value. It's a negative log of the Ka value, just as the pH is the negative log of the H plus or H3O plus value. So this is going to be negative log of 1.8 times 10 to the minus 5. So looking at this number, we know that the pKa has to be somewhere between 4 and 5. And so it turns out that the pKa for this acid is 4.745. And so that's the first answer for this problem. Now let's focus on the second answer. What is the pKb value? Now pKa plus pKb adds up to 14. So to calculate the pKb value, it's going to be 14 minus the pKa value. So that's 14 minus 4.745. And so the pKb value of this acid is 9.255. And so that's the second answer for this problem. Number 6. If the hydronium ion concentration is 7.1 times 10 to the minus 2, what is the hydroxide concentration? Go ahead and calculate it. So first, in this example, I'm going to calculate the pH. It's negative log of H3O plus, or negative log of this number. So I should get an answer somewhere between 1 and 2. And so the pH is 1.149. So now I'm going to calculate the pOH. So that's 14 minus the pH. So 14 minus 1.149 is 12.851. So once I have the pOH, I can easily calculate the hydroxide concentration. It's simply 10 raised to the negative pOH. So that's going to be 10 raised to the negative 12.851. And so that's 1.41 times 10 to the minus 13. So that's the concentration of hydroxide in a solution. Now, it turns out that there's another way to get the same answer, and it's using the autoionization constant for water. Kw, which is 1 times 10 to the minus 14, is equal to the product of the hydronium ion concentration and hydroxide at 25 degrees Celsius. So the hydroxide concentration is going to be Kw, which is this number, divided by the H3O plus concentration. So it's 1 times 10 to the negative 14 divided by 7.1 times 10 to the minus 2. And so you get the same answer, 1.41 times 10 to the negative 13. Number 7. If the pKa of an acid is 3.7, what is the Kb value of the acid? So first, let's calculate pKb, which is going to be 14 minus the pKa value. So that's 14 minus 3.7. 14 minus 3 is 11, and 11 minus 0.7 is 10.3. So now that we have the pKb value, to calculate Kb, it's simply 10 raised to the negative pKb value. In this case, that's 10 to the negative 10.3. And that comes out to be 5.01 times 10 to the minus 11. So that's a simple way to calculate Kb from pKa. Now here's the last one. Calculate the pH of a solution if the hydroxide concentration is 0.015. So the first thing I would calculate is the pOH. It's a negative log of the hydroxide concentration, which is 0.015. And so that's going to be 1.824. And then just calculate the pH, which is 14 minus the pOH. So 14 minus 1.824, that's 12.176. And so that's all the problems in this video. Hopefully this gave you a good understanding of how to calculate pH and pOH. So let's review some of the basic formulas that you need to know. So keep this in mind. pH is equal to the negative log of the hydronium ion concentration, or H plus concentration. And the pOH is the negative log of the hydroxide concentration. And then the pH plus the pOH has to add up to 14. Now if you need to calculate H plus or H3O plus, it's simply 10 to the negative pH. Likewise, the hydroxide ion concentration is 10 to the negative pOH. And H3O plus multiplied by OH minus is equal to 1 times 10 to the negative 14. Now, in a similar way, pKa is negative log of Ka. And pKb is negative log of Kb. So Kb is the base dissociation constant, Ka is the acid dissociation constant. Now, just as pH plus pOH adds up to 14, so pKa plus pKb is 14. Now, if you need to calculate Ka, that's 10 to the negative pKa. And Kb is 10 to the negative pKb. And finally, Ka times Kb is 1 times 10 to the minus 14. So those are some formulas that you want to write down and make sure you know if you're taking an acid-base chemistry test.